All right, so section 4.5, number 16. I like this problem because it kind of combines the aspects of everything we've been trying to do tonight. We want to basically do a linear approximation of the cube root of 65. So a couple of things is they didn't give us an a, so we're going to have to pick an a. Is there a cube root close to 65 that I know? Now 2 times 2 is 4, 4 times 2 is 8, so we're way beyond that. 3 times 3 is 9, 9 times 3 is 27, 4 times 4 is 16, 16 times 4 is 64. So let's let a equal 64, because I do know the cube root of 64. Oh, and by the way, it just so happens that when they do a problem like this, they're going to pick something close to something that you probably know. That's the whole basis of this. But I also don't know how to take cube roots as a function. So I want to rewrite f of x. Well, f of x, instead of being the cube root of x or the cube root of a or whatever it is, I'm going to call it, instead of that, I'll call it x to the 1/3. Which we do that all the time with square roots. We say square root of x is x to the 1/2. We never have an issue with that. Based upon that now, I can say that f of a is equal to 64 to the 1/3, which is equal to 4. We just calculated that a few minutes ago. But I can also say that f prime of x is equal to, so it's 1/3 times x. I got to subtract 1 from 1/3. So subtracting a 3/3 from a 1/3 puts me at negative 2/3 is what that puts me at. So then f prime of a would be, and you could type this into your calculator, 1/3 times a, which again, a at this point is 64. And then 64 is going to be raised to the power of negative 2/3. And if you type that into your calculator, I got it worked out right here, you're going to get 1 over 48. All right. So now I have both of those, and we know from our formula for linear approximation that it's equal to f of a plus f prime of a times x minus a. And that comes again from point slope form. Okay? And so in this case, we can take our numbers. F of a is 4 plus f prime of a is 1 over 48 times x minus a, which is 64. X minus 64. And that's what I come up with. So so based upon that, I can say therefore, the cube root of 65 is approximately equal to L of 65. This works out kind of nice, right? Because what we get is we get 65 minus 64, which is 1 times 1 over 48. So it really becomes 4 plus 1 over 48, or 4 and 1/48. Well, that makes sense, right? If the cube root of 64 is 4, we're going to expect that the cube root of 65 is going to be a little bit bigger than 4. And that's exactly what we just determined right there.